So we're kind of we're backtracking a little bit because we wanted to keep all of our shapes that were alike together. So we're in 11.3 today, and we're going to talk about the surface area of pyramids and cones. So let me grab a picture of a pyramid, and I'll turn this one. There we go. So there's our pyramid that we're going to work with here. And the easy way to draw a pyramid is just draw your parallelogram, this kind of pyramid, parallelogram for the base, put a dot up there, and then just connect that dot to each corner, and you have a nice pyramid. All right, so a pyramid is a polyhedron. And we're going to make a list of all the and we'll label our picture with all the different things that our polyhedron, this pyramid, has. Our pyramid has a base, and our base is a polygon. So for this pyramid, there's our base. Our base is a polygon. It has lateral faces. And lateral, again, just means side. Lateral faces are triangles. So all the triangles here are lateral faces. So this would be a lateral face. The lateral faces meet up here at the vertex. So the vertex is the tip here. The lateral faces meet each other at lateral edges. So these parts where the lateral faces are coming together, we call the lateral edges. We also have a base edge, or base edges. So the base edges are where the lateral faces meet the base. There's listing all of our different pieces. So those are kind of the parts of the outside. We name a pyramid by the shape of its base, just like a prism. So our pyramid's named by the shape of the base, so we could call this would be a square pyramid if that base is a square. So just like our prisms, named by the shape of the base. And we're also going to draw in our altitude / height. We use the words kind of to mean the same thing. They don't actually mean the same thing, but we kind of use them interchangeably. So our altitude, perpendicular from the vertex to the base. So this would be our altitude here, and it makes a 90-degree angle with the base. So I'm going to call that the height. That's how we find the height, is that segment. So we call the length, the segment is the altitude, the length is the height. We'll just call it the height. And then we also have a slant height. And our slant height goes from the vertex to a base edge at a 90-degree angle. So our slant height would go along the side of the triangle, like so. So our slant height is perpendicular from vertex to base edge. And I'll just say to base. So this red segment would be our slant height. And I'm going to draw in one other segment. I'm going to draw in the apothem of the base, because we end up with this nice right triangle that is inside of pyramids. So this right triangle that I have in red here, that comes up a lot in solving problems with pyramids. So we have this right triangle inside that pyramid. A regular pyramid means we have a regular polygon for the base. And when we have a regular pyramid, our altitude comes to the center, to the middle of the base. In this book, unless they tell you otherwise, we're talking about regular pyramids. So unless they say otherwise, our pyramids are regular, and our altitude, where we find our height, goes to the very center of the base. And just like with prisms, our lateral area is just the area of the sides. So that would be the area of the triangles. And the base area is just the area of whatever our base is. So those two things mean the same thing. So these are all of our parts, all of our different parts of our pyramids. The height, the slant height, and the base are going to be our keys for our formulas. Those are the really important things. And sometimes we have to use various different other parts to find those things that we need for our formulas. So questions about the pieces of our pyramid and how we're going to talk about them. Okay, let's draw a net. I want to draw a net for a pyramid to show where the formulas for the surface area formula comes from. So we don't just make them up, they come from looking at each shape separately. So our net for our pyramid. Pyramid nets have kind of a nice shape. So we end up with I'm going to draw a square or rectangular pyramid. So our base, just to make it easy to draw our net. So this would be a net for the pyramid we just looked at. Our triangles are sides. Our sides are triangles. So we end up with this nice kind of star shape. And I know my drawings don't always turn out perfect, but we get the idea. So there's our net. The slant height, if we draw in our slant height on our net, our slant height is the height of this triangle. So there's our slant height. And this is our base here. And I'm going to call the length of the sides of the base S. And we call our slant height L, script L. So S for side. So what's the area of one of these triangles? The base is this side, so the base is S. The height is L. So what would be the area of one of these triangles? 1/2 S L. And for this pyramid, we have 4 of them. So our lateral area, the area of the triangles, is for this pyramid 4 times 1/2 SL. Well, a base has 4 sides. Each of them is length S. So if I have 4 S's, what does that tell me about the base? S plus S plus S plus S. What is that for the base? I'm adding all the sides of the base together. What do I get when I add all the sides together? The perimeter. 4 times S is the perimeter of the base. So I could write this as 1/2, and I'm going to put the L first. 4 times S is the perimeter. So the lateral area is 1/2 the slant height times the perimeter of the base. And the base area, if we wanted the surface area, we would just add the area of the base. So to find our surface area formula, we're going to add all of the triangles. That's 1/2 LP. It doesn't matter how many sides my base had. I would still have to add, if I had a hexagon, I'd have to add up 6 sides. So I'd have 6 times 1/2 SL. And 6 times the side length would still be the perimeter of the base. Doesn't matter how many sides I have. So my lateral area is always 1/2 LP. And then we just add the area of the base. So that's where our formula comes from, is adding up the areas of the triangles of the sides. And then we add the base. So let's write our formula for our surface area. So our surface area of a regular pyramid. So unless it tells us otherwise, we're talking about a regular pyramid. So our surface area is going to be 1/2 LP plus B units squared. L is the slant height. P is the perimeter of the base. And B is the area of base. One-half LP is the lateral area, and capital B is the area of the base. So questions on our formula? All right. So I want to show you, before we do any problems, I want to show you just a little picture, a demonstration. I talked about the right triangle that's inside of pyramids. So I want to show you before we do these, just so we see them. We always can make a right triangle with the height, the apothem, and the slant height. So that's this triangle here. So we can use that to solve problems. If we know the length of the side, we can always figure out the apothem. So we can use the Pythagorean theorem. We also get a right triangle between the slant height, half the base, and one lateral edge. So we get a right triangle along the face, one of the lateral faces of a pyramid. So sometimes we need to use that to solve problems. And we also get a right triangle with the height, this lateral edge, and halfway across, half the diagonal of the base. So all of those are right triangles inside of pyramids that we can use to find missing pieces. There are more that are there, but these are the three that we use most often. And that very first one, with the height, the slant height, and the apothem, we end up using that a fair amount. And on my little models here, that's marked, this is a cone, but on the pyramid, the slant height is in red, and then the apothem is in red, and the height is the post here in the center. So you can visualize that right triangle that's in there. And these will be up here when you take your test, so you can take a look at those models to help you visualize these things. All right, so let's solve a couple of problems using this formula. We'll start with an easy one. So we're going to find the surface area. And a lot of times the problems were asked this way, just in words. Surface area of a square pyramid with base edge of 8 centimeters and slant height 12 centimeters. So a lot of times the problem is asked all in words, no pictures. So what should we do? Let's draw a picture to help us know what we're talking about. So here's my picture of a square pyramid. There's my base, my vertex, there's my pyramid. The base is a square. It says the base edge is 8 centimeters. So that's 8 centimeters. It says the slant height is 12 centimeters. So here's my slant height. There's my slant height. And it says that is 12 centimeters. Well, I have everything I need here. We know that the surface area is 1/2 LP plus B. Well, the slant height is 12. What's the perimeter of the base? What's P? 8 times 4, which is 32 centimeters. And the area of the base is the other part we need. The base is a square. So what's the area of the square? 8 times 8. Each side is 8. So 64 square centimeters. So I plug everything in. Our surface area is 1/2 12 times 32 plus 64. Half of 12 is 6. 6 times 32 is 192. And we get this equals 256 square centimeters would be our surface area. So this one was nice. They gave us everything we needed. Our base is our key, and for pyramids, for the surface area, the slant height is the key. All right, questions on that example? Let's take a look at another one. So this one we'll do a square pyramid again. So this time we do have a picture. So here's our picture for this problem. Square pyramid. So I'm drawing my square pyramid. And we have this side is 9 inches. And for this one we have this. And I know my drawing's not perfect. This is 8 inches. And we want the surface area. What's our problem here? We know our surface area is 1/2 LP plus B. Well, the B part is easy, the area of the base. We can figure that out pretty easily. The perimeter's good. What's our problem? We don't have the slant height. We need the slant height. So this is like we were talking, like our activity the other day, this is our hidden question. What is the slant height? Or what is missing? So let's draw in our slant height. If we don't have it, let's draw it in. There's a slant height. And I'm going to draw this nice little triangle. This is a right triangle. And I'm going to redraw that triangle over here, so we can work it. So here is the height. Here's the slant height. And here's the piece we drew across the bottom, the apothem of that square. So this is 8. And if this is a square pyramid, what's going to be the length of this side? Half of the side of the square. So half of 9 is 4.5. I'm going to call this L for the slant height. And now we can use the Pythagorean theorem on this triangle. So we just have to do a little bit more work. So we know that L squared equals 8 squared plus 4.5 squared. So L squared equals 64 plus 20.25. 4.5 squared is 20.25. L squared is 84.25. Take the square root of both sides to get L. And finally I get that my slant height is about 9.18 inches. So we just had to take a little detour there to find our slant height. So we have that part. What is B? What's the area of the base? The area of the base is 81. 9 times 9 is 81 inches squared. And the perimeter of the base? 36. 9 plus 9 plus 9 plus 9. 4 times 9. So now we're set. Our surface area is 1/2 the slant height, 9.18, times the perimeter of the base, 36, plus the area of the base, 81. When I multiply this out, I get 165, about 165.2. $165.2 is going to be 246.2, and my units would be inches squared. Questions on that example? So be very careful with what you're given about pyramids, because sometimes they give you parts and you need to use those parts. This right triangle that's inside your pyramid defines your other pieces. All right, let's talk about cones. Cones are a lot like pyramids, but the first thing we need to say about cones is they are not polyhedron. Why are cones not polyhedrons? What's the base of a cone? Circle. What are polyhedrons made of? Polygons. Circle isn't a polygon. So a cone is not a polyhedron. A cone is a solid with, and we're going to talk about our parts of our cone. So let's get a picture of a cone. Your cone, just draw a kind of a flattened circle and a dot up here at the top, and then connect the sides to the circle. Just a touch bigger. So our solid with a base. What's the base of a cone? We just said it. Circle. Base is a circle. Lateral surface. Our lateral surface is just a curved surface, and we'll talk more about what that curved surface is in just a second. So our base is this circle. Our lateral surface is this curved surface. Our altitude or our height. Just like for a pyramid, perpendicular from the vertex to the base. So this segment would be our, I'm just going to call it the height, that's where we find the height. And we also have a slant height on a cone. Our slant height is from the vertex to the edge of the base. So on this cone, our slant height would be right along here. And this would be our radius. If we have a right cone, for a right cone, and we forgot to say the vertex. The vertex is right here at the top. So base is a circle, we also have a vertex. Vertex is the tip of the cone. For a right cone, the height, the altitude, goes to the center of the base. So in the book, if they're talking about a cone, you can assume that they're talking about a right cone unless they tell you otherwise. So we're usually going to be talking about a right cone. So there's our pieces, our picture of our cone. What I want to do is do exactly like we did for the For the pyramid, we'll draw a net for the cone and talk about where the surface area formula comes from, and then we'll do an example of calculating with that formula. So everybody good with our parts of our cone? Okay. Net for a cone. So net for a cone is kind of an interesting shape. So what I'm going to do first is draw a dotted line circle. And what we do to make a cone is we cut out a piece of this circle. So I'm just going to cut a piece out of that circle, a wedge, like so. And this part that I've traced in red, that's my lateral surface for the cone. And so let me show you. So what I've done here is I traced a circle and I cut out a lateral surface for a cone. And what you do with this lateral surface, you fold it around so the two edges meet, and there's my cone. So the two edges meet, there's a cone, and it's hard to see the base. The base is a circle. I have to hold the edges together here. But my cone, there's my base is a circle. So I bring those two edges together, and that makes my cone. So lateral surface is a piece of a circle. And then the base would be a circle that's attached here. And our base would have. So the edge, the lateral surface for a cone is kind of like a curved triangle. The lateral surfaces for our pyramid were triangles. So our cone is kind of like a pyramid. Well, the length of this side of the triangle, if we think of this as a triangle, the length of that side of the triangle has to be the same as the circumference of this circle. Because when we wrap the cone around, the base has to fit right around that edge of the lateral surface. So the base of our triangle, and I'm going to put that in, or think of this as a triangle, the base of the triangle is 2 pi r, the circumference of this. They have to fit perfectly with each other. The height of this kind of curvy triangle is the slant height. This is L. Because when I put these two edges together, that's the slant height that's right down the side of my cone. The height of the triangle is L. So the area of this curvy triangle, and I'm going to say the area of the lateral surface, is 1/2 the base, 2 pi r, times the height. 1/2 of 2 is just 1, and I just get pi r L. So the area of the lateral surface is pi r L, and then to find our surface area, we add the area of the base, which is just the area of that circle, pi r squared. So just like we did for pyramids, we add the area of the lateral surfaces, the triangle, and here the triangle is kind of curved, plus the area of the base. So that's where our formula comes from. So our surface area formula. So surface area for a right cone, and we can assume we're talking about a right cone unless we're told otherwise, is pi r L plus pi r squared, units squared. R equals the radius of the base. L equals the slant height. And we can think of this pi r squared is B, area of base. So we have the area of the sides, one side for a cone, plus the area of the base. Just like the formula for a pyramid. We added up the area of the sides, which were triangles for a pyramid, added the area of the base. Here, our side was just one kind of curvy triangle, so we take the area of that and add the area of the base, which is a circle. All right, I just want to do one example calculating with this formula. Let me back up really quickly, and just as a reminder, inside this cone there is a right triangle between the height, the radius, and the slant height. You will have to use that to solve problems that have to do with cones. We have a right triangle inside of cones, just like we have a right triangle inside of pyramids. So let's do an example, and then we'll go over our homework quickly. We want the surface area of the right cone. So here's my picture. And we're going to say that's 3 centimeters, and this is 12 centimeters. So we have our slant height. If it would have given us the height rather than the slant height, we would have been able to use the Pythagorean theorem to find the slant height because we know the radius. So our surface area, pi r L plus pi r squared. So we just plug our numbers in. Pi times 3 times 12 plus pi times 3 squared. 12 times 3 is 36, so I get 36 pi plus 3 squared is 9 pi, and I get 45 pi centimeters squared. So this would be my area, surface area in terms of pi. If they would have given us the height instead of the slant height, I could have used the Pythagorean theorem to find the slant height. I know the radius, I know the height, I can use the Pythagorean theorem. The right triangles inside of pyramids and cones, you will need to use those to solve some of these problems. All right, questions? Okay. Homework? There we go.